In this video, I'll be showcasing my partner Aiden's and my final project for computer networks, where we built a DNS server using Rust. I'll start the video with a background on how DNS works for people who don't know. If you want to skip directly to the demo, then skip to the timestamp on your screen now. So what actually happens when we type google.com into our search bar? How do we actually connect to the Google website? Over the internet, computers talk to each other using IP addresses, which are long strings of numbers such as the one you see here. So we need something to convert google.com into an IP address representing Google. And this is exactly what DNS is. It maps URLs to IP addresses. And you might be thinking, why bother? It's because humans are much better at remembering things like google.com than they are at remembering 142.90. blah blah blah. So it makes more sense to allow humans to type a URL like google.com and then have a DNS server in the background convert it to an IP address. So domain names are read right to left and they are organized in a hierarchy. So for example, take cs.brown.edu. On the very right, there is an implicit dot that represents the root server. And then edu is the top level domain, and Brown is an organization that's registered under the .edu namespace. And finally, CS is a subdomain that Brown has registered, which represents its computer science department. Now, no single DNS server knows every domain on the internet because that would be impossible. Instead, each level has its own set of DNS servers that only know who is responsible for the level directly above it. So for example, when our computer wants to find cs.brown.edu, it walks down the hierarchy asking for directions. So we start at the root server and we ask the root which IP corresponds to cs.brown.edu. And then the response we receive will be, I don't know, but you can ask the next highest server, which is .edu. So we go to the .edu server and ask what IP corresponds to cs.brown.edu. And the response will be, I don't know, but you can ask the next highest server, which will be brown.edu. Once again, we ask brown.edu and it does not know and refers us to the cs.brown.edu server. And finally, when we ask cs.brown.edu which IP corresponds to this domain, we receive a response. And that is how DNS resolution works. So now we will talk about iterative versus recursive lookups. So what we just saw is how iterative lookup works. There are public fast DNS servers, such as these two IP addresses, which are owned by Google and Cloudflare respectively. And these are offered as a service to the public and can provide better security or privacy for certain people. And how recursive lookup works is that we make another DNS server, such as one of these, do the iterative lookup for us, and then we cache the result on our own DNS server. So with that, we are ready to get into the demo. This is Alan and Aiden's final project for computer networks. We built a DNS server in Rust. We can start the server from the command line by passing the port that we want to listen on, as well as whether we want to use iterative or recursive queries. We'll demo the recursive queries first. How the program works is that it'll just pass the query on to a public DNS server, such as 8.8.8.8, and then return the result directly to the user. So for example, if we dig for google.com and we get this IP back, we can verify that it does match Google. And we can also do this for AAAA as well as CNAME record types. If we query for a website that does not exist, then we'll receive an NX domain error in response. Next, I'll demo the iterative queries for which we implemented ad blocking and caching. So if we run the iterative query type, for example, if we dig something like google.com, you can see that the first query takes 393 milliseconds, but then all the subsequent queries will take a much shorter amount of time, 60, 55. And this is because we're caching the result. And for future queries, we can just look it up in the cache and find it immediately. We also have ad blocking. So if we dig for a URL that is in this list, such as doubleclick.net, then our DNS server will return a fake IP address, which is 0.0.0.0. And basically any traffic that wants to access doubleclick.net will be redirected to this fake IP and be unable to connect to it. Our ad blocking also works for the AAAA record type, which returns IPv6 addresses. It will simply return the default null IPv6 address.